Okay, so here's a how-to video. I'm gonna explain how to think in visual binary, how to think digitally. Computers use bits, ones and zeros, to convey information, and a lot of the time we can classify our thinking in visual binary categories. And so here I'll see if I can do it. If I can show you how. So for example, if you want like a 2-bit system. All right, it started with 1 bit, right? If you want a 1-bit system, you have to be able to tell the difference between a 0 and a 1. So let's say a 1 is a line and a 0 is a space. So here you'll have a 1 and a 0. So let's say this is a 1, this is a 0, where a line is a 1 and a space is a 0. Now, if we wanted to add a bit, we would say to have 0, 0, 0, 1, 1, 0, 1, 1, what we would do is we would have to have 0, 0, 0, 1, same like that, 1, 0, and 1, 1. Why is it like that? So you have verticals and horizontals now. So now you can think in vertical and horizontal. So the second bit is vertical, the first bit is horizontal, if that makes sense, right? So see if I can draw it correctly. Right, so now every time you add another bit, the number of permutations doubles. So say this is our say this is we're using this diamond shape to calibrate, right? So say this is the first bit, this is the second bit, this is the third bit, this is the fourth bit, this is the fifth bit, this is the sixth bit, this is the seventh, eighth, ninth, 10th, right? So say now we have this diamond calibrating 10 bits. We can even calibrate more bits, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So now say we have a 22-bit visual binary interface, and we can recognize these by human eye and webcam, right? So in visual binary, these lines represent ones and the spaces represent zeros. You can have any combination of lines and zeros, of lines and spaces representing ones and zeros. And the advantage, now let's think in an alphabet of visual binary. A visual binary alphabet that's 22 bits has so many applications. For example, here, just take a look. We've got friendship cube, which I'll explain in a minute. It is a visual binary code, but these around the same calibrated diamond symbol, we have these 22 symbols that actually represent letters. So you can, because it's intuitively arranged for you to actually be able to read it. So I'll explain. The vowels are A, E, I, O, U. They're horizontal because you're literally making these sounds with your with your voice box, but you're vibrating A, E, I, O, U. All right, the next symbols are B, P, M, F, V. B, P, M, F, V. B, P, M, F, V. So it's shaped the way it sounds. I'm talking about an alphabet that looks the way it sounds, right? Or that's shaped the way it looks. There's going to be an intuitive connection in your brain, a visual binary neurosignal connection between shape and sound. between phonetics and geometry, between light and sound, you're going to start seeing light shapes that represent sounds and sounds that are light shapes. And using using this visual binary 22-bit code, you'll be able to interface with a larger visual binary intelligence, and you'll be able to do things like hands-free typing, like silent hand-free typing with neural signals acquisition devices like the Emotive Epoch from Emotive Life Sciences. So I'm going to explain the next classes of letters as I was going to. You got A, E, I, O, U, B, P, M, F, V, B, P, M, F, V. Now we're going to have X, C, H, W, L, D, T, N. So you're going to H, S, H, W, L, D, T, N. So these sounds, imagine this diamond shape is this calibrating shape, and these shapes, H, S, H, W, L, D, T, N, you're making them with your tongue, but it's the same idea of this diamond being the calibrating center, just like in a QR code, where you have a symbol that calibrates and then a visual binary code, where there's ones and zeros. Imagine now in your mind, connect these bits X, C, H, W, L, D, T, N the same way we did A, E, I, O, U, B, P, M, F, E. These symbols are X, C, H, W, L, D, T, N, H, S, H, W, L, D, T, N. The final four symbols in the visual binary alphabet of the friendship cube are R, S, Y,